Right, here's where we left off. That would be your problem number 2. Now, the normal distribution and the standard normal distribution. The normal, a continuous distribution, is most important in all distributions. It shows up all over the place. Psychology, business, econ, economics, sciences, nursing, and math. And it comes up at, this is true, some of your instructors, especially in college, may use it to determine grades. The curve is symmetrical about a vertical line drawn through the mean, which is mu here. In theory, the mean is the same as the median because the graph is symmetric. As the notation indicates, the normal distribution depends only on the mean and the standard deviation. Since the area under the curve must equal 1, just like all probability distributions, a change in the standard deviation causes a change in the shape of the curve. So if you've got a standard deviation that is, one standard deviation is way from the mean, who calls it to be fatter, okay? If you've got one that is very close to the mean, it will become narrower. A change in the mean would cause it to go left or right. All right, the standard normal distribution is what we'll discuss next. When we had this problem, you notice the scale, and then we did the cereal box, and I drew a little short one right there doing the same thing with a different scale. So every time we have a different problem, you have a different scale, and it makes it difficult to compare your sets of data. If you've got a specific standardized score that depends on the standard deviation away from the mean, then you can compare things, compare one set of one set of data to the next set of data. I could compare this one to the one that I drew for the 565 or the 6,000 boxes. All right, to standardize a normal distribution, you'll take the x that you're dealing with, you subtract the mean, and then you divide by the standard deviation. And this takes you from your scale that you've got here to a standard normal distribution, which is your 1 standard deviation, 2 standard deviations, and 3 standard deviations. So when you are dealing with things like we just had, instead of doing what we did before, the 220 would have a z-score of 1, or -1, because it's below the mean. This would have a z-score of +1. This has a z-score of +2. This has a z-score of -2. This has a z-score of 3, and this one has a z-score of -3. That is standardized, so that you could then come over and compare it with the one that I drew. It's had the 565 here, and a standard deviation of 5. So we had 560 to 570. Now you can compare it because the 560 has a z-score of 1, and that 570 has a z-score of 1. So for each of their data, the 260 and the 570 are comparable. You can now compare them. This is from a website, Math is Fun. I don't know if you can read it down there, but I do have a link on the page that also goes through the entire standardizing a normal distribution on that page. So if you need a little bit of extra reading, that's where you can go. All right, z-scores. If x is a normally distributed random variable, and this is what it looks like, your x is the normal, the n, that's in mu, and that's your mean and your standard deviation. Then the z-score is x minus mu over the standard deviation. So this would allow us, for instance, to find a z-score for, say, 230. You know, it's between the two. We don't know what it is. but we want to find a z-score for 230 to compare, and that's where this formula would come in. You would put the 230 minus your mean, which is 240, divide by the standard deviation, which is, in this case, your standard deviation was 20. So that is a negative 10 over 20, which is a negative 0.5. So the z-score of 230, in between the two, is 0.5. Negative 0.5, as a matter of fact. So, values of x that are larger than the mean have positive z-scores, and the values that are less than the mean have negative. If x equals the mean, then x has a z-score of 0. That's what we're dealing with here. Okay. So, the standard normal distribution is a normal distribution of standardized values of z-scores. It's measured in units of the standard deviation, just like we just did. If the mean is 5 and the standard deviation is 2, the value 11 is 3 standard deviations above the mean. The mean is 5, standard deviation is 2, so we go 7, 9, 11. That would be 3 above z-score of 1, z-score of 2, z-score of 3. Okay? And once again, you could put it into this 11 minus 5 divided by the standard deviation of 2. 6 divided by 2 is 3. That's how that all relates. Okay. The mean height of 15 to 18-year-old males from Chile from 2009 to 2010 was 170 centimeters with a standard deviation of 6.28 centimeters. Male heights are known to follow a normal distribution. Let x equal the height of a 15 to 18-year-old male from Chile in 2009 to 2010. Then there is your normal distribution, how you would write it out. Okay? Suppose they were 168 from there. The z-score when x equals 168 is, okay, we've got the 170 is our mean. So you're going to do 168 minus 170 divided by 6.28. Okay. So 168 minus 170, negative 2, divided by 6.28, means my z-score is negative 0.3185. This z-score tells you that x equals 168 is negative 0.3185 standard deviations to the left of the mean, which is 170. Suppose that the height of a 15 to 18-year-old male from Chile from 2009 to 2010 has a z-score of 1.27. What is the man's height, the male's height? The z-score tells you that the male's height is 1.27 standard deviations to the right of the mean. And to get that height, you would substitute it in. 1.27 equals the x that we do not know minus the 170 over 6.28. I would cross multiply that. 6.28 times 1.27, and I get 7.98 7.98, roughly, we'll round it off a little bit, 7.98 equals x minus 170. So if I add 170 to both sides, I can find out that this male's height was 177.98 centimeters. Okay? So, recall the empirical rule that we talked about at the beginning today. The scores on a college entrance exam have an approximate normal distribution with mean 52 points and a standard deviation of 11 points. About 68% of the y values lie between what two values? Well, you've had a mean of 52, so it would be plus 11, which is 63, and minus 11, which is 41. Okay, 41 and 63. The z-scores are -1 and +1, respectively. So once again, add 11, subtract 11, and you get 30 and 74. 30 and 74. The z-scores are -2 and +2, respectively. About 99.7% of the y values lie between what? You got minus 11 on that 30, which makes 19, plus 11, which makes 85. So these values are 19 and 85, and your z-scores are -3 and +3. So we're going to wrap up video number 2, and I'll see you in a minute.